All right, everyone, let's get the show started. Welcome to our DevOps office hours. Today it's September 8th, 2021. My name's Eric Osterman, and I'll be leading the conversation. I'm the founder and CEO of Cloud Posse. We're a DevOps accelerator, and that means that we help companies own their infrastructure in record time by building it together with your team and showing them the ropes. So if that sounds interesting, head over to cloudposse.com/quiz to get started. Again, that's cloudposse.com/quiz to get started. For those of you new to the call, the format is very informal. My goal is to get your questions answered. So feel free to unmute yourself at any time if you want to jump in and participate. If you're tuning in from our podcast or YouTube channel, you can register for these live and interactive sessions by going to cloudposse.com/office hours. Again, that's cloudposse.com/office hours. Our call today is recorded. We host these calls every week. We'll automatically post a video recording of this session to our YouTube channel, as well as syndicate it to our podcast, so you can listen to it however you feel. With that said, let's get started here. I have a number of announcements. Like the number one announcement has come out and been posted a few times in our Slack community is HashiCorp has come out quite honestly and said, hey, we are kind of pausing right now and reviewing pull requests and answering issues because we're short staffed. And I think that's something that anybody hiring for Terraform and DevOps type of skill sets is feeling right now. It's really hard to manage. Now, HashiCorp, this was posted originally on their GitHub community health site here, adding a note that due to low staffing that this is happening. I guess there's also a new blog post. I haven't had a chance to review. This came out yesterday, kind of explaining a little bit more like what's going on here. But basically, they're just seeing explosive growth of the community, adoption, the number of issues being open that they're swamped. So hey, one option is, if you're looking for your next opportunity, I'm pretty sure HashiCorp is looking to hire. Anybody else have any background on this issue and what's going on here? I will say I empathize with where they're at. I mean, Cloud Posse is a much, much smaller company than HashiCorp. But the thing is, we manage already like 300 plus repos across all our projects. And it is enormously difficult to stay on top of the number of issues and pull requests that we get, even as a small company. So imagine the enormous stress that HashiCorp has. I mean, 1,000 engineers is probably not enough to get to it all. The other announcement is exciting. So anybody running smaller workloads on Kubernetes, EKS, coming maybe from a COPS background to EKS would be surprised to know that the number of pods you can run on an EKS node is very low. It depends on basically the size of your instance and the number of ENIs that you can attach to that instance. So in AWS, one of the nice things is your pods are not served by an overlay network. They are actually given their own dedicated network interface. So that's why pods and networking on Kubernetes work really well in the AWS ecosystem. But that also means that Amazon, in a tricky kind of way, found out a way to charge you for the number of pods you want to run on your node, is one way of looking at it. Kind of like, your VMwares or Oracles of the world want to charge you based on the number of CPUs you have or something. Well, Amazon did that by restricting the ENIs on a node. So that is a limitation. However, they did come out with one nice thing very recently, just here at the end of August. It came across my radar yesterday, which is you can now assign a CIDR prefix to an ENI. So if of up to /28, and that means you can get at least 16 additional IPs per ENI. So you could say that that is effectively a 16x increase for the number of pods you could conceivably run on a node. I haven't looked at what this looks like from a Terraform perspective or from an infrastructure as code perspective, how easy or hard this is to take advantage of. Has anybody already looked into this? Come on, Vlad, I know you have.
I think is just a flag on the Amazon VPC CNI. I haven't tested it.
Okay.
It's not of interest to me. Like, I'm sorry.
Okay.
The problem with this is I very much like having an ENI per pod because it makes debugging network flows very, very easy. As
Yeah.
somebody that had to fight with overlay networks, I'm very, very happy not to go back to debugging that while a cluster is scaling up and down can lead to some very, very interesting networking
Yeah, it just
bottlenecks
hurts
and
that when
things
some
I don't
smaller
want.
instances have like 4 ENIs and you can have 4 pods per node, and that's just stupid.
I agree with that. And this doesn't support a security group per pods because
Ah,
a
that's a
bunch
good
of
point.
pods are sharing a single ENI. There's
Yeah,
no way to do security groups,
of
which
course.
is
Yeah.
not exactly ideal. I think this is covered at the end of the blog post or something. They do
Okay.
discuss the trade-off. I I'd be curious if there's a performance trade-off. I wouldn't expect one.
Yeah, that's interesting. What was I going to say to that? This was not the solution I was expecting, but I'm glad they at least came up with something. I'm sure they're continuing to maybe look into how to add more ENIs. Oh, one other important caveat here is this only works for Nitro instances. So you can't just take advantage of this if you're not already using Nitros. However, if you're not already using Nitros, you should be, because they add another really nice feature, which is a certain subset of Nitro instances, I forget which ones, automatically add transit encryption within your VPC. So take advantage of that.
You could never memorize the list. It's like 27. It's like 27 different patterns that to identify which subset of Nitros support.
Yeah.
It's like definitely the N Nitros support it, but then there's a whole bunch of other things. But
yeah. And it was a little bit confusing. Even I remember when we were looking it up, trying to get the definitive list of what those were. Yeah, so all right, I won't waste the time trying to pull it up here, but just be advised that's available now. Moving, Brian Ty, I remember this is something that he was excited for or needed.
Something related-ish. EKS Anywhere just went GA, literally when this call started.
No, really?
Yeah.
So this is the ability to run your self-hosted EKS platform?
Yeah, Amazon can kind of manage EKS in your data center, which is something.
That's interesting.
Give me a second. I am posting the link now in the office hours channel on Slack. And oh my God, I did not. Yeah, it has the tracking thingy at the end. Now edit.
That's fine. It's one of those, it doesn't get me all excited because I tend to avoid opportunities that involve bare metal, but I could totally see companies that, would be more excited about that than I. All right. Another minor announcement. This was just something came across my radar last night as I was talking to Alex in our community. Alex is a regular contributor and a participant. So Spacelift supports native webhooks on their platform. However, this is a small little Lambda you can deploy to control more fine-grained controls over where the notifications would go from events happening in Spacelift and to which channels and which states you want to be notified. And even if you want to notify an individual user versus a channel. So it's something interesting. There is another feature coming out of Spacelift relatively soon, which we are excited about, and it's better control over webhooks and the payloads of your webhooks. And we're going to be using that to integrate together with Datadog and Opsgenie so we can really escalate how those notifications are handled to make sure like drift is escalated in a different way from like build failures or deployment failures. All right. And the the last announcement that I have is coming out of Cloud Posse. Just for those like following where we're headed here, we have been working on a new Terraform module for AWS's client VPN. This is a alternative for self-hosting your own open VPN service. It does integrate with SAML, and it works together with ACM self-signed certificates. So we're trying to make this the most robust client VPN module out there. From what we've seen, many of them are lacking some support target routes, while others don't. Some support multiple subnets, others don't. Some support SAML, federated SAML, others don't. So we're trying to really support everything within this module, and building it on top of obviously all of our other modules that we have for ACM and self-signed certs and security groups, etc. So, and CloudWatch groups, etc. So check it out. All right, any other interesting announcement from the past week? Anyone? No other announcements? All right, here. Well, then let's move on to then the Q&A. So I dug up a couple of questions that I saw throughout Slack. And the first one is from Sheldon. So Sheldon is a regular in our community. And the exciting thing there is that Sheldon has just started tackling Kubernetes. So he is learning there and had some questions kind of for Kubernetes newbies. Do you recommend if you had to deploy your own company's apps, should you jump right into using Helm or customize, or should you first kind of kick the tires on writing raw Kubernetes manifests? And similar to that, how do you get started? Like if you already have maybe lots of Docker compositions, should you do what Sheldon did? Maybe use Compose to translate those rapidly to something in Kubernetes that you can deploy. So I'll give a few thoughts on this. I'm sure lots of others have other thoughts on this, and I'll turn this around. I see you, Jim, there nodding your head. I'll ping you there. So my thought on this is you should always crawl before you walk a little bit. And this isn't saying that you're going to go live to production writing raw manifests, but I think it is really important to understand some of the fundamentals and how Kubernetes works as a framework before you start immediately jumping into optimization. Just like if you are learning Terraform, I totally support, and you should absolutely use Terraform modules, but I don't think you'll appreciate all the effort that goes into Terraform modules if you first don't just get the basics down and write a few of your own Terraform resources. It lowers the bar. You'll have more sense of satisfaction and accomplishment earlier. You won't be overwhelmed. And I can't help but say, like, a lot of people, when you start out with these things, is like, it's just adding complexity, or it's just adding indirection or layers, or adding more tools. And I get it. We've all said those words at some point, but it rubs me the wrong way always. Like, that's just because there's, we don't always understand the steps and the thinking that got us there. So once you go through some hard lessons learned, some of those rudimentary parts, then you'll appreciate, now I understand why there's this Helm chart for Prometheus, because I don't want to go write 500 resources and deploy and manage those manually. And I don't know anything actually about Prometheus low level, so I'd rather use this Helm chart that somebody else provided and is an expert at it. Just be advised that when you start using those Helm charts, they move pretty fast. Like Prometheus, this is one reason why we don't use Prometheus anymore. Like it's like you get up and running really quickly. You're victorious within 5 minutes. Look there, I deployed a full Kubernetes Prometheus cluster in no time. And then, like, if you're like us, we started when it was over at Ticketmaster, and the Ticketmaster gave it to CoreOS, and then CoreOS gave it to Kubernetes stable, or like, the github.com/helm/charts, but then that got deprecated. So then it got splintered out into 10 different organizations that are all managing their own Helm charts. So just like with Terraform and modules, you kind of got to pick your vendors, and hopefully that vendor is pretty good at maintaining ongoing support for those. I'm drawing a blank right now. There's one company out there that provides an enormous ecosystem of Helm charts for like everything, from WordPress to what, Jim?
Bitnami.
What? Bitnami, thank you. Yeah, exactly.
Yeah.
So the Bitnami charts is one of those great ecosystem for Helm charts I recommend checking out. So next question, follow up to that, should you be writing Helm charts for your own company? Well, I think two things is, I think there are three considerations here in making this decision. So I've assumed now you graduated from writing manifest, you understand why you want to dry things up. Now you need to figure out how do you want to dry things up. So I think Helm is phenomenal as an open source distribution model for apps. And Helm basically lets you package up all the nastiness of deploying a Kubernetes resource and expose a simple interface that you just provide YAML values. Keep in mind that YAML values, there is no bona fide schema that spans organizations. Any developer can come up with any schema they want for your Helm chart. So this is one of the nastinesses that we get with Helm. So when it comes to deploying open source pieces, I think you should basically standardize on using Helm. That there's little room for negotiation if you talk to me about that. But if we're talking about deploying your company's apps, then I think there's a few ways this might go. And how you generate those manifests will be based on kind of what resonates with you. The two leading strategies that I see is mostly using Customize or Helm. All of our customers are currently using Helm still, but I see what's nice with Customize is what you are templating looks a whole lot more like the final product and doesn't do text file based templating on YAML data, on YAML data structures, which has always been kind of awkward. But the reason why the community went that way was that you could at least visually kind of see what that YAML would look like, versus if it was a data, like if it was a DSL for generating your YAML. It's elegant from a programmatic standpoint, and it's impossible from a community standpoint, like conveying how to use that DSL when it never will look like what the documentation from that vendor said. So that's my point there. So the last thing I wanted to say is keep in mind what you want your continuous delivery model to look like for Kubernetes. Because if you're going to go with tools like Flux or Argo CD, one of the end results there is you're actually reducing it all down to the raw manifests themselves. So the tool choice matters a little bit less, and the outcome is you're defining the state of your resources in a Git repository however you want to do that. I still think that using Helm to generate those manifests is a great solution, and committing that, or using Customize or some other solution. So I'll stop there. Jim?
Yeah, I mean, I think you've really called out, from my perspective, like the key underpinning to making that choice of how you're going to templatize and to what degree you're going to templatize your Kubernetes manifest. It really comes down to how many variables do you have, right? Like if you're talking about an open source project that a bunch of people are going to be using to install your stuff, you have to account for all those variables and how they're going to consume it.
That's true.
So that means Helm chart, right? But if it's just your company and you're deploying it to 1, 2, maybe 3 environments, and your variables are much less, maybe you're changing a name here or there, maybe you're changing a subnet group or something, then maybe you don't need the complexity of the Helm chart. Maybe all you need is a simple customize or maybe even a text-based YAML modification, right? Like you have a make file, make some changes. I
Just to
think
get
that's
started,
okay,
yeah.
just to get started. Or even, or even this is the lowest common denominator, right? Have 3 sets of manifests that you copy paste back and forth. I mean, I'm not suggesting you do that, but that's also
That's how you kind of
viable.
get
Like
started, kind of learning like,
Yeah.
oh, I can't keep you do that until you realize, oh, I can't keep doing that. But then you've matured to the level that you can maybe open up and use the other tools.
I think the trap of manifest languages with YAMLs and Kubernetes manifests and Terraform manifests is also a manifest language. I think the trap there is really making variables out of things that don't need to be variables. And I see this over and over and over again. People will say like, oh, it's over parameterized. It's like, you don't need that. It's a manifest language. You can actually use what somebody called disparagingly magic strings.
Mm-hmm.
It's a manifest. It's supposed to have this data in it. So it's okay. And just think about I would say, think about the consumers who's using this product, who needs to parameterize it and only include the necessary parameters. And I think that will lend the answer.
Simplify it great. And the key there is like when you are building this open source, you'll naturally see it be parameterized to the nth degree, versus if it's for your company, really you only need to parameterize those things that vary, things like the image tag and maybe resource limits. But you don't need to parameterize just to parameterize. What you don't want to have to, like the config, the Kubernetes manifest, that is your config. It's already parameterized. It's parameterized for Kubernetes. You're just adding one extra layer of kind of parameterization on that to dry it up. Any Vlad maybe, or Matt Calhoun, anything to add to that?
Yeah, I don't know. First of all, how many environments are there gonna be? Like, does it make sense? Because at some point, everything you're doing with halt is just copying the same YAML, but it's more complex YAML.
Mm-hmm.
If you're just introducing more complex YAML, does it make sense? Another thing I would consider is how much automation do you have around this? So with Helm, it's really nice to be able to just do Helm list and get nice versioning links and application names and all that. It's awesome. You can do rollbacks. Maybe not the best idea, but you can do rollbacks and things like that. But you've got to set up a Helm chart repository. It's not terribly complex. There's a way to do it on S3 that's pretty easy, but you have to do that. You have to secure that. You have to do a bunch of things. It might be easier to just have YAMLs copy pasted because that's easier, and you can do some interesting automations with GitHub Actions on that. You're not, I don't want to say limited, but you don't have to follow the same strict workflow of get the Helm chart and now do things and play with parameters. You can just directly modify the YAML. There are advantages and disadvantages to both. I know this is the kind of thing that depends wildly, and I'd love to have a general rule or a valid starting point. For this, there's not. And recently, Terraform is also getting not terrible with their Kubernetes providers.
Thank you for bringing that up, because I was going to say that this is also your other option. I think once you graduated from doing the raw manifest and you want to start looking at tools, well, don't rule out using Terraform. Maybe you're not going to use Terraform for your application deployments, but for the backing services inside of your Kubernetes cluster, like cert manager or external DNS or reloader, or some of those are the common ones we deploy. Terraform is a great candidate for those. Last week we did talk about, I think it was last week, came up about or the week before that, some of the deployment patterns with Argo CD. And then somebody brought this to my attention, which is Argo CD Autopilot, which is under the Argo CD, Argo Project Labs organization. And I guess the primary sponsor behind this is CodeFresh. But this is not a CodeFresh centric solution or pattern. So I'm really curious to check this out, because it's the first kind of semi-official reference architecture for how to deploy and manage Argo CD. So check that out, and we'll share this link. I bring that up because of the tie-in here with how to deploy your apps ultimately with to Kubernetes, be it Helm or otherwise.
Yeah, hi. Hi. So recently, I don't know if I'm about the Kubernetes thing. I don't know if anyone can hear me.
Yeah, I hear you. Hear you, MM.
Yes. So I actually joined the company recently that the person who was there before was using customization, and I think it was kind of hard to manage it, especially because I came from a background where I was using more of Helm, and also like having to like go into each of those services one by one and then write my deployment file, write my all those files was really hard. So what I kind of always, because I've actually used Kubernetes for a bit, not that good, but I had to like, I always have a base Helm chat, like that base Helm, that base that kind of contains everything. I think in everything I do, I kind of just want to have that base guide that kind of contains everything that is going to be used, that is redundant, that is always going to be used and all. Then I think I used three ways of doing it. I had a base Helm chat, and then I actually also introduced Helm files.
Yes. Yeah, Helm files. It's almost cruel of me not to mention Helm files. We are still a major user, and not we are a proponent of Helm file, but I see diminishing returns with Helm file now as the ecosystem has matured. So where we were 100% gung-ho on Helm file originally, as a Terraform shop, and with the advancement of the Terraform Helm provider, we see diminishing returns using Helm file if you're already using Terraform. But if you're not using Terraform, then Helm file is not a bad option.
I think Terraform is hard to use on Kubernetes. I feel it's too much. Like, I don't want to use, my company currently uses Terraform to manage GitHub, and I'm like, what? No, I'm tired. I just want to use Terraform and just do the basic stuff I need to do, like build my whole infrastructure. I don't want to use it for Helm file. I think for Helm. I think just leaving Helm to just be on its own for me is just easy. Like, you're not putting everything together. To me, I think so though.
Yeah.
I don't.
What's nice about that is then you don't have to worry about the state management, and you can just run Helm file and whatnot.
You can't even use it without Helm file. You could just use Helm without like having to use Terraform and all. And then because I use GitLab, so I will just pass it through GitLab and then just use and GitLab has the ability to do almost everything. Even
so you actually bring up a really good point, because I don't think I emphasized this enough. So we talked about how, like, if you're writing all these raw manifests, it's going to get boring real quick because it's not very dry. So then you're going to need Customize or Helm to wrap that up. The funny thing is, then you start doing all this Helm, and then you learn that, WTF, these values files are static. I can't have variables in there. What the heck were they thinking? So then you realize you need another abstraction on top of Helm. And that's why you have tools like Helm file, which let you define your entire application release across all of these diverse set of Helm charts that you might have.
Yeah, especially with multiple environments. Yeah.
Yeah. And much the same way you would use Helm file for that, an alternative to that is you can use Terraform. It's kind of just what fits with your worldview on how to deploy to Kubernetes, and there's no right or wrong.
Okay.
Yeah. So yeah, thanks for speaking up, MM. And anything else you want to add? Anybody else have anything to add to this topic? All righty, let's get to the next question, which was, how do you all run databases on Kubernetes? And this was a question from Pierre. And before we go into just directly answering how to run databases on Kubernetes, I think we need to define a couple of the use cases of why one might want to run databases on Kubernetes. And just off the top of my head, I can think of three pretty good ones. So one is you are running on bare metal in your own data center. and you don't have access to fully managed alternatives to databases like RDS, Elasticache, Redis and Memcache, et cetera, et cetera. So that's one use case. Hey, you have this platform, why not use it to run your database? Two is you need short-lived databases. And that is like you're deploying your apps to Kubernetes as part of preview environments or like Heroku review apps or these short-lived environments. And spinning up infrastructure for a preview environment is overkill. It's like using a bazooka when you needed a BB gun. It also takes a lot of time. Like provisioning an RDS database might take you 15, 20 plus minutes, and deploying a container takes you like 200 milliseconds. So that's a strong argument to be doing. The third argument is cost. And I think we need to be careful here what cost means. When Cloud Posse got started in 2015, my whole vision was, hey, there's so much open source to do everything we're paying all these SaaS companies for, and we have Kubernetes. Why don't we achieve, this is my hypothesis at the time, greater economies of scale by just deploying all this open source onto our platform? So for APM, we were deploying Sentry. For monitoring, is Prometheus or Grafana. For Elasticsearch, for logging, it was Elasticsearch. And it goes on and on and on and on. And we were deploying a huge stack on top of Kubernetes. And the great news is there were no more vendor agreements that had to be signed, and the licensing costs went to zero. But the overhead skyrocketed, and the tech debt became insurmountable for the smaller companies that don't have dedicated teams. Look, the companies that operate things like Prometheus and Grafana at scale, or like actually operate it, have teams dedicated just to managing those things. And the teams that say they do it but are just deploying a Helm chart just haven't been doing it long enough to learn why they don't want to do it anymore. Because once you get to one of those major upgrades, it's gnarly and you're terrified of losing any data. So you don't upgrade and you stay behind just because you're afraid of breaking anything. So when it comes to running your databases on Kubernetes, and when I say you might know you're doing it for cost reasons, it's not because you don't want to pay a SaaS provider necessarily. It's because you need to run 10,000 databases because you're a WordPress hosting company, and running 10,000 RDS databases would be ridiculous. Or you're limited on just kind of some of the ways you could use maybe RDS, or your company for some reason leverages some proprietary Postgres plugin, and you can't install that on RDS, so you have to run your own database. So that would be the other scenario that I think about. So how do you do it? Well, for those short-lived preview environments, for the short-lived databases, we're not talking like day 2 operations. We don't need backups. We don't need restores. We don't need high availability. We don't need to worry about any of that stuff. Dude, just use that Helm chart we were talking about earlier. Just deploy it with Helm. It'll come up real easily. The architecture and best practices are managed by the community. However, if you are now concerned with how you're going to actually manage day 2 operations for that database, this is backups and restores, this is automatic failover, this is upgrades. This is where the concept of operators come in. So if you're just using raw Helm, you are the operator, the human. But if you want to have this programmatically managed for you a little bit more, you can use an operator. And I can't speak from firsthand experience because we basically do not recommend to our customers for anything mission critical to use Kubernetes for it. Not because Kubernetes is the problem. I wouldn't recommend you to do it on your bare VMs, on your bare EC2s for the same reason, but just because it's complicated. So there is a company called KubeDB that specializes in this, and they have an operator for every major database out there. And what's nice about this is it adds commercial support if you want it. So they're open source with commercial support. The problem with operators, like this has come up before, like the best explanation is Helm issues, CRD. I'm not going to find it in time. But there's a long write-up by the Helm community on just like why custom resources are great, but then like why they suck a lot. And the problem with custom resources is if you delete the operator for the custom resource, every resource that it manages is also deleted. That kind of sucks when it's your database. When you are running a custom operator, yeah, it's versioned, and you cannot today run 2 versions of that operator concurrently. So it's kind of like, hey, this is your control plane for all of your databases. Your whole business depends on it, and you're going to go upgrade this operator, and you really don't know what the outcome of that's going to be. And worst case, it's totally hosed. You can't even delete it, because if you delete it, it just deleted all your databases. So you are cornered in to being a pretty hardcore Kubernetes admin if you're really going to be managing operators at a production scale for mission critical applications where everything's on the line. So this is my biggest problem, is that a lot of people get started with Kubernetes, a lot of people get started deploying these things, and it's so freaking easy, but they don't realize what the day 2 operations are along with that. So maybe that's why it's also good to go with a company like KubeDB, not speaking from experience, or it is not an endorsement, but somebody who's going to provide you support on that might not be a bad idea. There's also something called Operator Hub, which provides a directory kind of like the Terraform registry. And this was also recommended here. You can filter for operators on a lot of the databases out there. But dude, when you check out these operators, look at like the commit history, the activity. It seems like operators are like, everybody who wants to learn Golang, this is like one class of weekend projects. Hey, I'm going to write an operator for deploying MySQL databases. So you'll find a lot of operators that were created over a weekend and then never touched again. So what is my recommendation with all that said? Yeah, just try and use managed services as much as you can, and then use Helm for the things that you don't care about, and operators last if you absolutely need something to manage the life cycle.
Can I ask a follow-up question?
Yeah, go for it, Jim.
It sounds like the recommended takeaway from this conversation is like, if it's not ephemeral, don't put it into Kubernetes. Generally,
that's our overall approach. We try to take, and even like things that are stateful, like we use EFS so that it still persists, even if that pod bounces across nodes and it's not locked there. But I mean, this is a nice to have. Like, some companies don't have that liberty. I'm just saying, push it off as long as you possibly can to external backing services, so your Kubernetes clusters are ephemeral. And again, I don't want this sounding like I'm not saying Kubernetes is not ready to handle it. It is more ready to handle it than you running it in your own self-managed auto scale group with chef recipes and Ansible. It is just as bad as that, and I don't like that other solution either. So for those reasons, I want managed stateful services.
So I mean, this reminds me, like in our company at Script, we have some Kubernetes clusters, and upgrading those clusters is just a tremendous pain. Just so much effort goes into transitioning applications in place in a Kubernetes cluster. Do you know of a better way? I thought to myself that maybe it'd be better if we just spin up a brand new net new cluster and then just migrate applications over. And if they were all ephemeral, then it really wouldn't matter, because we could bookend those applications with backing services and load balancers.
Yeah,
that's been my thought, but I haven't seen that in effect.
So I only know from kind of like this is not even firsthand experience. I only know one company by like, as in somebody who's in our Slack community that I've talked to a lot, and that's Brian Tai at Audit Board. And they are one of the few companies I know that do blue-green clusters, and they've invested a lot to do that. And then there was this message, I don't know if it was snarky or not. I think it was from Kelsey Hightower, but his whole thing is like, and this is me doing a horrible job paraphrasing it, but my takeaway was, why are you guys treating your clusters as pets? They should be cattle, right? And like, okay, great, but show me the money, because it is so hard to do once you start depending on anything stateful, even going down to things like load balancers. And you can't, and you have third parties that are, you know, referring to that load balancer address. Maybe you're CNAMing it, maybe, but there are other cases where like you might need to use a global accelerator, and then you have the global accelerator sit in front of that, and then that would help get away from the problem of them you know, talking directly to the load balancer associated with one cluster. The key is that you gotta architect your apps in such a way you can actually do those kinds of things. And the other thing I really don't like about it, so like for all the, I love it from the perspective that you can use it now to upgrade your platform, like literally bring up a duplicate version of your platform, run them concurrently, and then flip one off and move it over. What I don't like about it, I don't like people thinking about, now we're going to do our application releases to blue-green Kubernetes clusters. And that just seems so super heavy-handed. And I think it's an abuse of thinking about what Kubernetes is. Like, it should be thought as a platform whose life cycle is not coupled to your application releases. That life cycle is different. Yeah.
I was talking about doing, like, you know, migrating to Kubernetes itself, the
Yeah,
control plane itself, not the applications themselves. The applications, like if they're all 12-factor, right, then they can go to a new place, and if they're all pointing at the same, like if they're ENI based, and they could point to, you know, whatever load balancer to their register. If they're part of a service mesh, then they can update themselves in part of the service mesh. Like at the top and the bottom, like of the north to south stack, right? The Kubernetes plane has to coexist with another Kubernetes plane that can talk to the same resources, right? And then you could achieve the rollover effect. We did this a lot at Pivotal when I was with Cloud Foundry. Like our Pivotal web services, which runs on Cloud Foundry, and is also a container orchestration system, kind of like Kubernetes. Like we rolled that every 2-3 days, right? And we rolled like 50,000, 40,000 containers. But we had a guarantee, and the guarantee was that everything in Pivotal Web Services must be a 12-factor app. It must be able to handle signal 15, go down gracefully, and it will come back, but in a different instance. And so with that guarantee, we can make that roll. I think that we could do the same with Kubernetes based off of what you were saying earlier about only putting ephemeral stuff in there.
Yeah, I think that's the key there. Anything to add to that? Yeah, Vlad?
I can confirm. So a bunch of my customers are doing this actively, doing blue-green deployment for Kubernetes clusters. It's, yes, if they're 12-factor apps or 12-ish factor apps, it's super easy to do. If you do cell-based architectures, that's also easy to do, because you can just start up a new cell kind of ish or migrate from one cell to another. If you do feature flagging, there are easy way to do it. Super lightweight way of doing it is just putting the Route 53 health check stuff in front of it that handles the migration from one load balancer to the other. There are a lot of options depending on what you want to do, but yeah, it depends a lot on how the application is architected and what the outcome of it is. I mean, yes, we're doing blue-green upgrades for clusters. We're not doing it in place. We're treating our clusters as cattle, not pets. And besides the tech badge that you get, like, what's the benefit? For a lot of companies, there are benefits. For others, not really. There's also, yes, I can talk about this. There are also companies that launch Kubernetes clusters on demand. I think AWS had a blog post at some point about launching a Kubernetes cluster from a step function, doing work in there, and at the end, tearing down the Kubernetes cluster. That's also a very dynamic Kubernetes-based workflow that works great in practice.
I would just hate trying to debug that. Oh my gosh. All right. I think there's even an operator for it too. Like you can have an operator that provisions up a net new Kubernetes cluster. So you have Kubernetes creating Kubernetes.
How do you
Or one of
bootstrap
my
that though?
What was
You
that,
have
Matt?
a management
How do
cluster.
you bootstrap it?
Yeah, that's the problem. You got to get the first one.
if you guys want something even more sinister, and I don't recommend this at all, one of my public Helm charts uses Kubernetes in Docker and GitHub Actions in order to spin up a Kubernetes cluster in Docker, run some tests, and then tear it all down. It's so fat. I really don't like it. I wish I never did that.
But you got it working. That's
But I got it working. But it's just a lot.
crazy. All right.
I can confirm I'm actively doing that too. And it works fine. It's terrible, but it works fine.
And then Mike Frida was asking a question in the channel if anybody's using these tools, tfexec or a similar one, tfinstall. And yeah, we're not using it. I think he was expressing he had some issues running it. I didn't realize HashiCorp had this tfexec tool. Looks relatively young. Anybody check it out? Oh, so this is a wrapper for Go to call Terraform. Interesting. Cool.
I've literally started looking at this, but I don't know Go, so I'm looking for interest in anybody who has opinions and has worked with it before, especially if they have some code samples.
Mm-hmm.
This is
But essentially, yeah, you're right.
major...
It just gives you ability to run Terraform and Go, and it has some nice semantics for like provisioning like the correct Terraform instance like version. If you have like say like in my case, I'm using it for multiple Terraform workspace directories with different Terraform versions. So I've been able to kind of start to multiplex, like creating just running Terraform plan across several Go routines at once. So I've only started looking at it, so I'm sure I think someone else was trying something.
Yeah, that was me. Not being able to run Terraform programmatically is one of the biggest drawbacks of Terraform compared to CloudFormation. So if you're doing SaaS, for example, and you need to create a bunch of resources on demand from code, you're pretty much gonna use CloudFormation because Terraform has terrible support. Like there is this wrapper and there were a bunch of others. At some point there was a library for Bash that helped call Terraform and interpret the output, which was no. So yeah, this is a major feature that is missing from Terraform. There isn't a lot of demand for it, so I can see why. Like it's very specific. Not a lot of people want to call Terraform apply or Terraform plan from code. But yeah, this is a huge miss and it's not going to get fixed.
Yeah, I would add one thing that was very interesting. Starting with Terraform 0.15, I think. I'm not sure if you all caught this, but you can output your Terraform plans in JSON now.
Yeah.
Which this could take advantage of Terraform exec here. I'm not sure the extent of what you can accomplish with it yet because I haven't finished looking at it, but it is promising.
I bet that was prep work for this kind of thing coming out. What were you saying, Matt?
Yeah, I was gonna say I've looked at this pretty extensively a while back. So I'm a former maintainer for TerraGrunt and TerraTest, and we wrote all of our own plumbing to do all of this basically initially, and we strongly looked at trying to migrate over to this and let HashiCorp maintain all the guts of shelling out and making all the calls and doing all those things. And it looked pretty robust and pretty feature complete to me as far as doing everything that we needed to do. But I never actually got around to doing the work because that was not high on our priority list to do that. We had a lot of other things going on at the time.
So this looks like it's like less than 12 months old, right? This is pretty young.
Yeah, there was a predecessor to this that they released that was the library
Okay.
to actually call this, and then they moved it all into this repo basically. But it was probably in like just about a year ago, or a little, maybe October of last year, that I kicked the tires on it and did all the work and looked at it.
Yeah. All right, let's see. So that's all I had. Let's jump over, see, are there any other questions? All right, well, maybe are we out of material for today? Final call.
I wasn't planning on sharing this with y'all, but like if there's a interest, I could talk briefly about some of the work that I've recently open sourced.
Yeah.
Has a set of GitHub Actions for manipulating AWS App Mesh. I'm not sure if anybody uses App Mesh,
Oh, interesting.
but I've got a set of actions that you can use to stitch together AWS App Mesh and ECS for in this particular example, which I'll post a link. In this particular example, you could use it to trigger a new build off of a pull request, and then create that build and create a virtual service, a virtual gateway route that points a particular host name to that virtual service, enabling developers to have a what I call a pull request preview. You've seen this in other companies do this, but this is just an open source example of that.
That's cool. No,
So,
I haven't spoken to many who are using App Mesh. So, and I don't mean that as a criticism or anything derogatory, I just haven't had opportunities. So knowing that you're working with it, how has that been working out for you? How's App Mesh? Is it making your life easier at all? Would you continue to deploy it the next time around?
well, it's like if I had the choice between that and Istio, I'd probably pick Istio, but we don't use Kubernetes for this stack that I've been working on. So it's not really a choice. I mean, for those that don't know, like App Mesh is a simple wrapper. So the way App Mesh works with AWS is that AWS App Mesh, the service, is essentially like a configuration management tool that you tell AWS what you want your Envoy to be configured as. And then when Envoy spins up, it talks to the AWS API, gets its configuration. And so like essentially what AWS is doing for you is they're giving you an API to configure your Envoy instances inside of, say ECS in this example. So that's what that is.
What other options?
I like it fine.
What other options had you considered before managing App Mesh with the GitHub Actions, or was that pretty much the natural solution?
So there for the work that for the result that I wanted, which is the pull request resulting in a build being deployed and being made available to developers, GitHub Actions was really the only. There's products like Flex. I think FlexCD was also something I considered. Okay. Was it FlexCD? Is that the GitOps one?
Yeah, exactly. Yeah, that is.
I'd also consider Flex, but I wasn't sure that they would work for my stack.
And in this particular case, what is the benefit to using App Mesh for the routing as opposed to ECS with just like target group based routing on host names or paths?
Yeah. So I guess I could, like, to your point, I could have created like a Route 53 record and then had created a load balancer and then registered a new ECS service to those load balancers, right? But all of that takes time to do, and the latency for that. While I haven't tested, I just presume that it will be in the order of minutes. if I have the app mesh configuration and the service mesh sitting there waiting for requests to come in, and a load balancer already up and running with a wildcard Route 53 record, and as requests come in, if there's a matching virtual gateway route, then it gets routed to the correct virtual service. And that configuration can get deployed in a matter of seconds.
Sounds really nice.
And and then all I have to do on backend is have my ECS service up and running, waiting for requests and register.
And that takes a few minutes, but yeah.
Right. That takes a few minutes, right? Yeah.
Just to be clear, though, the other kind of benefit to this whole thing is it doesn't just have to be ECS or a single load balancer. You can, with that mesh, you can point it to every, Fargate or EKS or ECS or EC2 instances across multiple load balancers. Like, you have a lot more flexibility with your routing config than the other suggested thing. So,
and to the point earlier
across
about
load
the
balancers,
clusters.
you could also be across accounts as well, by the way. You could share your service mesh with another account, and then they can participate in the service mesh as well. So,
and API gateways, that's another thing. Yeah.
So it was partially because one of the reasons why I chose to do it this way was partially because it was new, and I wanted to know. There's a little bit of resume-driven development there for sure.
Yes. RDD.
Also, a little bit of RDD, but yeah, it was. It's interesting. There's this. I'm working with AWS support right now because there's a particular limit in the number of virtual gateway routes you could have per virtual gateway, which seems kind of arbitrary. And anyways, just be warned that you can only by default have 10 virtual gateway routes per virtual gateway. And
sounds very low.
Yeah, and yeah, that's.
Do you know what that's the hard limit or that's the soft limit, or you don't know yet?
Oh, I had to learn this too, so I'm not going to assume that everyone knows this. So let me share something that I learned about the stack. There's several elements in that mesh configuration, and if you're not familiar with Envoy or Istio, then this is a learning thing, and it was for me because I wasn't familiar with those. But the entry point to a service mesh is your virtual gateway. That's what registers itself to load balancers. That virtual gateway has virtual routes. Gateway routes. Those gateway routes define the matching configuration, like if it's host name or if it's a host header, or a header. And it basically says, if you match these parameters, then point to this virtual service, right? Then the virtual service is underneath that and says, hey, I'm pointing to a virtual router. There's another configuration you can point directly to virtual node, but that's just generally don't do that. Just virtual service points to virtual router. That virtual router points to several virtual nodes or another virtual router, but generally nodes. Those virtual nodes. So what happens with the virtual nodes is that you have elements come up, whether it's on ECS or whether it's on EKS or whether it's on EC2. You sidecar your Envoy proxy, right? And it registers itself as a virtual node, right? And that forms the exit point of that service mesh. So again, from top to bottom, it's virtual gateway, which has virtual gateway routes, right? Which points to a virtual service, which points to a virtual router, which points to several virtual nodes, and that exits to your on the south side to your application.
Makes sense.
So I had to learn that. So that's your kind of brief run through if anybody's interested.
Really interesting, Jim. Thanks for speaking up on that. I'm curious. I think we should internally at the Cloud Posse do a POC on it. Looking forward to it. All right, we are out of time for today. So thanks everyone for participating. Learned a lot. It's really interesting about the App Mesh stuff here. If you haven't yet subscribed to our YouTube channel, head over to youtube.com/c/Cloud Posse. Again, subscribing to our channel helps us out a great bit and increases the visibility of our channel. If you haven't registered for next week's office hours, go ahead and do that at cloudposse.com/office hours. Again, that's cloudposse.com/office hours. We host these calls every week, and we will be having our next one, same time, same place next week at 11:30 a.m. Talk to you then.
Thanks, Eric. Thanks, everyone.
Right, thank you.
Thank you.